Okay, my friends, I'm going to go kind of quick because I've been told I have to make these a little quicker. Now, everybody who knows me knows I have DNA tested ancient giant human beings and regular sized human beings. This is DNA tested and it's a lung. This is DNA tested and it's a fingertip, so that's a giant. And I have the whole hand to this, and I have the knuckles and all kinds of things. And it's been DNA tested as human, and it's excellent quality DNA, same thing here. And I have another one, it was also a giant. Now, and I'm saying they also come through space. And you say, oh, well, let me tell you what, that right there is also a fingertip. And I say that came through space. And you say, well, how can you say it's a fingertip? And how can you say it came through space? Well, it's all burnt off like that. And see this? Okay, this is literally the structure that makes a fingertip. And you have blood on one side, which is artery blood, and vein blood on the other side. Artery blood just blows right out, and it blows out from here, and at the very tip there's also a blowout spot. That's where the blood can blow off in the artery. The vein side is here, and up here, but it doesn't blow out. They don't blow out because they have clamps. And I can show you that on a terrestrial one. Now again, I say that came through space. Here's one identical. And when I say identical, we're talking identical. This is the vein side on this one. This is the vein side on this one. This is the fingertip hook on this one, the terrestrial one. This is the fingertip hook on the one that came through space. You see how perfectly, exactly that is? You see how this side, the blood just ran out, because this was on Earth. This one is exploded because it was wet coming through the atmosphere. Literally exploded out of here. And this is one of the anchor balls that was in the fingertip. And it had that strap coming wrapped right around here and strapped back to the tendons that hold and grab, make your fingers really strong and tough. That's a tendon ball. And I can show you this on the anatomical drawings and so forth. That is an anchor. Now, look at this. You see that circle? You see that circle? There was another one over here, and that one blew off. These are the tendon emplacements that make this fingertip be able to articulate, just like these fingertips. And that's the back of it. All right, and this one had the same thing. Only you can't see the circles on this one because it didn't burn off the way that one burned off. This still has like fleshy stuff on it. This one burnt the flesh off. Remember I told you? Maybe it didn't, I don't know. Maybe. But they burn off and the slag burns off. This is the more structural part. The bodies are constructed just absolutely phenomenal. And there's a circle on the end out here. You really can't see it all that well on this one, but there's a circle on, well, you can maybe see it, I've seen it a lot on this one. All right, you can see it here, you see that circle? That's the same as the circle that's on this one and the same that's on the circle that's on all of them, at the very tip. And what that does, that locks in a bunch of little tiny tendon balls into what they call an apical tuft, which I have one here somewhere. Oh, I'm sorry, my friends. Oh, there it is. This is what's underneath there. You see that whole circle right there? Let me put a little tiny taste of water on there and see if it becomes a little more visible. Probably not. But anyway, that is the circle. Right there. And that's where this is from from the same hand, I'm sure, because there's a bunch of highly eroded spots, and that would have been right there. And all these little fibers come up and lock in with balls in each of all these little holes. And it's right from this circle right here. And there's one on the other side too. See it right there? You can actually see the straps coming out of this one. It's right there. Human body is just amazing. Absolutely incredible. And anyway, that's a giant fingertip. And that's why you know, and it's DNA tested. And I can show you this in a microscope. We'll see the fibers, we'll see the blood, all of that stuff. And this is just one that was flattened out. They were all in the flood. Now, this one here preserved a lot more integrity, and the hand, the palm, is absolutely flawless. It's eroded a bit, but not much. That's not very deeply eroded. In the CAT scan, you can see where the fingernail was and all that stuff. And this one here just flattened out in the flood. See the bottom, just flat. And then the blood just sort of leaked out into the waters and so forth. And here's where the tendons were on this one. See, one here, one there, and then the bone runs up the middle. The same thing here. There was a tendon here and a tendon here. And the bone ran straight up through the middle. And these locked in down to the sides of the bone, and then the apical tuft was out here. And another one down at the bottom to hold everything together. And this ball here is what was an anchor. And there's one in space that looks identical to that. It's called Comet 67P. Alright, like I said, this fingertip was DNA tested. That is the hand. It's a left hand. And that's the pad, the bumper pad you have around yours. And that's the little tendon that runs down, which you will have if you splay your hand back like that. And this is the grip skin, which is the very tough skin. And it's totally different than this normal skin on your hand, on the rest of your body. And I have all kinds of parts from this. This is a knuckle. And see, it eroded like this. And the crazy thing is, half of it eroded down to where you can see the bone ball. And the other half still has the muscle. That's the muscle that surrounds that bone ball. And this is the tendon. You see that little round spot right there? Tendons have what they call abrupt transitions. So from here, you have a little strappy tendon, really tough. And then, whoa. Alright, so you see the muscle and the tendon and the bone ball, and that's the back, that's literally the back of your finger. And this is the tendon that runs down to whatever it connects to, the muscle. Now, this is another fingertip. I don't know if you can see this. This is the black pattern of the bone black of a distal phalanges. But anyway, here's your vein side, and here's your artery. Now remember, the veins don't blow out. There's the vein. And the other vein is right in here. Now, there's a hook to these two, and that hook holds it in. And this one here even has the hook right here. See it? See the hook? See it? Same hook? This one's obviously way eroded. But this is the same hook as you have over here. Now, this is the artery side. Artery blew out, artery blew out, artery blew out. You can even see the red blood inside the artery. The vein side over here didn't blow out, and the vein didn't blow out, and the vein didn't blow out. Alright, and that's the distal phalanges blown black pattern. Hold on. See, a little tiny smidge of water sometimes gives it a little better coloration. But anyway, that's the pattern, the bone black of a distal phalanges. Alright, you see that? That's the same thing. If this came through space, you'd end up with that. Look at the number of layers on here. I got a little water on here, but there's just layer after layer after layer. And that's what is in the tissue. People don't realize the number of layers in the fascia. It's just unbelievably saturated with layers. And everything, there's everything is in space is on Earth. There's body parts of every sort. There's hearts, there's lungs, there's kidneys, there's fingertips, as I showed you. There's little tiny lungs, there's big lungs. There's all kinds of different sized creatures, and I mean gigantic ones. And the lungs turn to that stuff I showed you over here somewhere. This stuff here. That's what lungs did. And I have one here that is a lung from Earth. which would be identical same thing. And if you can see you see it in the shiny stuff there, you can see all those little channels in there, that's where the blood went. And if it came through space, the blood would have boiled off in there and made a structure between the little holes, and the holes would show up the metals that were in them. That's why they're like that. Now I'll show, that's a lung. And as you see all the little tiny holes, let me show you a heart or a kidney. You see that? That's an iron lung. It's just like that. If this came through space and it was that big, it would smelt everything off, basically, until you got down to the iron, as the temperature you have to get to. Now, this was loaded with red iron, which is blood, because it was a lung. Now, this was a lung as well. It has all the same passageways, and I've looked at this pretty close. You could find the red blood in here, because there's still, in those passageways, you can see there's red in there. I don't know if you can see it in there, but I've seen some very close-ups of it. And deep inside, there's still some residue, possibly. Like like over here, I don't know if you can see that or not. But that's a lung, and so is this, and so was this. Only that came through space. Well, this one did too. All right, you see that? I don't know where this came from, but it's all these little dots, they call them chondrules. And this is an artery, and that's a vein. And that fed the tissue below this. But these balls don't burn off, but the little straps that were attached to them that cause your skin to be able to move. There's balls and straps. Now, I'm going to show you what I have right here. This is my belt. And it's in the microscope, and there it is right there. Now, those black spots are the balls. This is tan, so they crush them and smush them and everything. And all of these are the straps. The straps burnt off, and we could see all these little black spots. And you say the straps? What straps? Well, here's the straps. I'm going to go down to one of my belt loops, which is down here. Whoops, which is down here, that they get fluffy. And here's what it looks like there. Whoops. You see? You see the straps? Every one of those straps is attached to one of those black balls. You see the black balls? The straps burn off because they're burnable. Now the balls are much, much harder, and they turned into, you see those? These are the black balls. And that is exactly what you're seeing right there. It's the exact same thing. Only the one in the belt are not cooked, and these are cooked. The straps are gone. You see, the straps are gone. That's all. Alright, so that was skin. Every single body part is in space. This is a meteorite from NASA. I have this same meteorite here. Well, it's not a meteorite. It's a bonehead. You see, this is the same thing. That's the hole, that's the hole. This is the exact same thing as this. It's a bone, and this is the meteorite they claim from NASA came out of space. See, meteorite. Well, bonehead. All right, now what else we got here? All right, look at this. Now, this is a heart, or it could be a kidney. I said, I'm sorry, not a kidney, a heart or a liver possibly. And that's because it's literally 100% blood, which is what your heart is, almost 100% blood. There's a lot of structure to it, but it's just saturated with blood. And you can see the blood right here. There's the black, that's the vein, and there's the red, that's the artery. You see that? There's the red. I mean, it's pretty red to me. And there's a black, pretty black to me. Now, how did all these crystals end up showing up in here? Inside your body, in your blood, there is a bazillion different metals in here. Those metals crystallize at different temperatures, and they seem to come together. Now, this was cut across and polished. That's why you see this kind of structure. These metals try to congregate together at certain temperatures. And that's just another one of these meteorites. Now, whether that's a lung, a heart, or a liver, je ne sais pas. It is a meteorite. It is loaded with blood that has now converted to its metals because it has been smelted. Check this out. This is from the first mission, Curiosity, and a Mars meteorite. We found that up on Mars. It's the same thing as this. So they're everywhere in our solar system. They're crashing into us. There's the Kentucky meat showers. This is not something that's unknown. It's just that they refuse to engage because it just blows them crazy. It makes them out of their mind. And I have shown you that we have lungs, we have hearts, we have skin, we have, you know, everything, every body part, fingers, tips, and the whole 9 yards. They're all out there. Oh, here it is right here, Kentucky meat shower. Oh. This is back in 1876, I think. And for a period of several minutes, chunks of meat fell out of the sky. Absolute chunks of meat. At the time, Mrs. Crouch, when she was making soap on her porch, when she was reported seeing the meat pieces fall from the sky, she said she was 40 steps from her house when the meat started to slap the ground. The meat looked grisly, according to Mrs. Crouch, which is ripped apart body parts. You got all kinds of different things when a body rips apart. She and her husband believed the event signified a sign from God. Well, I guess it would. A similar event was later reported in Europe. The phenomena was reported by Scientific American, the New York Times, several other publications at the time. Now, this could have easily been one of these pieces of a body part. Now, I don't know how big the chunks of meat. They were only 2 by inch, 2 and 4 inches, 4 by 4 inches. They were, you know, they were little balls of meat, meatballs coming out of the sky. Now, when a body falls apart, it falls apart, and all the meat rips off. The meat's ripped off of this. This is the actual structure of the finger inside. This is the tendinous, tough stuff that makes your fingers tough. The rest is floppy, gooey. And you know, this has all the floppy, gooey stuff. Now, if that came through space, it would end up looking like this. It's the way it is. So this is not an unknown phenomenon. Okay, my friends, this is a channel called Professor Simon Holland. Very cool guy. Now, he's talking about extraterrestrial French rocks that fell from space. And the French, they went crazy because they couldn't understand what all these inclusions were. Now, I'm just going to play it. You can listen to it. Here goes.
There was a massive meteorite shower over Normandy and Brittany in northern France. But these weren't ordinary extraterrestrial rocks. These were the much rarer metallic meteorites. Solid metal, but with a strange property. Trying desperately to understand what they were made of, the French scientists found an amalgam, a mess.
All right, let me just cut right to the chase. You see what he's looking at there? That's a metal meteorite. You see all these little pockets? All these little iron pockets in there, they're filled with red iron. Now, this came through space, and everybody knows when you come through space, it heats up and they glow like crazy and they burn. So what it does is basically it smelts the iron and the metals that are in here. They smelt just like you would in a furnace. And I know this very well. Trust me, because my father was right there. They made stainless super metals. I worked on that car, 1936 Ford stainless steel. There was only, I think 6 of them were made only, and there's only 2 left in the world. I actually put the floor in that car, and they were floorboards. They were actually red oak. Anyway, that goes back. But trust me, I understand metal, and this is smelted, coming through space. But why would it be iron? Why would it be, and literally wet iron when it came through? Because I also have a meteorite here. And this had wet iron in it when it came through, and this iron exploded. It didn't turn into this kind. And the reason this turned into this is because it started from a different property. And I will show you exactly why this meteorite exploded out of the side here, this red iron oxides. And this meteorite here is, I can show you, it's, it's magnetic, and it's, I have that microscope going. We're going to be looking at all this stuff in a microscope. Whoops. But the point being is that the bigger they are, the harder they impact in the atmosphere, and the more they smelt. And the more iron that's concentrated in one area, the more metal you will get. We're going to be looking at a bunch of different meteorites, and I'm going to tell you right now, that's blood. That's a lung. Okay, so I obviously think I should be consulted on what the rocks that they're looking for on Mars and so forth, because let me show you what is on Mars. Those are the Mars blueberries. Those are nothing more than the little balls I showed you on my belt. This is the Mars crab. Guess what this is? These are sarcomeres. These little bundles are sarcomeres of muscle tissue. That is an artery, and that is the vein that comes back. Veins don't have a whole lot of little vessels sticking out of them. The arteries do, because they have to supply all that muscle with energy. Now, all of this red dust that's running off is the eroded blood, fleshy, bloody stuff. And what's left here is connective tissue. It's loose, floppy connective tissue, but that's what these blocks are. They're called sarcomeres. And that's, I'm sorry, it's just a fact. Then you've got Mars Morse code. That is nothing more than interstitium. This is stretched interstitium, and this is gathered interstitium. These planets were just gigantic. These are the little tendon balls. Remember I showed you the straps on my belt? Some of them were long. That's just exactly what this is. Now, it's eroded, and it's buffed. This is not, there's not a lot of water up there. There's a lot of, it looks like sandy-ish erosion, because these are the tougher parts. The straps and the balls. The balls are the toughest. So the straps erode, the balls are left. Alright, remember up on Mars, they had all these little breaks and all these little slats like this. These are sarcomeres. When they come together, that's how your muscles pull in, and then they relax, they come out. But this is what it is. These are the loose connective tissues, and these are the separations between the bundles of sarcomeres. Then there was a blood vessel somewhere coming out, because these all have to be serviced with a lot of blood. When you're running and you're doing a lot of work, you require a lot of oxygen, which requires a lot of blood. That's why you start breathing real hard, because you need to get some oxygen into these muscles when you start running and doing all that stuff.